Okay, the first part of this problem is going to be, once again, to verify that two given solutions are solutions of a differential equation. And again, the idea is to show that they make the equation true. So just like before, it's always best to start off with the difficult side and show that it equals the more complicated side. So we're going to start off with A times y1, which is the 2 by 2 matrix 3, -1, 1, 1, times the matrix or vector y1, which is e to the 2t, e to the 2t. Once again, we multiply these out. We've got 3 of the top one minus 1 times the bottom one. So that's 3 e to the 2t minus 1 e to the 2t. Of course, that makes a 2 e to the 2t. The other one is 1 e to the 2t plus 1 times e to the 2t. That's going to make 2 e to the 2t as well. And just by inspection, you can tell that that is the derivative of y1. So again, that equals y1. We're going to do the same thing for y2. However, this time around, it's going to require us to use the product rule. So we're going to actually find the derivative first. So for y2, let's first find the derivative. y2 prime is going to be equal to, using the product rule, derivative of the first is 1 times e to the 2t plus the first, t plus 2, times the derivative of the second, which is 2 times e to the 2t. For the second entry, derivative of the t plus 1 is 1 times the second plus the first, which is t plus 1, times the derivative of the second, e to the 2t. If we now multiply and combine like terms, we're going to have the 2 multiplying to both of those terms in the parentheses there. So that's a 2t. And then that 2 times 2 plus that extra 1 over here makes 5 e to the 2t. And then for the other one, it's a similar situation. The 2 distributes to the t and the plus 1. So that's going to make parentheses t again. And then we have that plus 2 getting together with that one to make plus 3. Times the e to the 2t. So that's the derivative of y2. Now let's go through and find a times y2. So now a times y2 is equal to the matrix 3, -1, 1, and 1, times t plus 2, e to the 2t, and t plus 1, e to the 2t. When I multiply this out, I'm going to have 3 times the t plus 2, e to the 2t, minus 1 of the t plus 1's e to the 2t. And then for the other one, it's 1 of the t plus 2, e to the 2t, plus 1 more of the t plus 1, e to the 2t. If I now go in and multiply and combine like terms, I'm going to have 3t minus a t, which makes 2t. And then I'm going to have the 3 times 2, making 6, minus the 1 makes plus 5, e to the 2t. And then down below, I'm going to have 1 times the t and 1 times the t again. Adding those up makes 2 times t. And then the 1 here and the 1 there is going to make plus 3 e to the 2t. And you will notice that that is the same exact thing as the y2 prime that we found a few minutes ago. So we've shown that a times y2 equals y2 prime, and we've shown that a times y1 equals y1 prime. So both of those vectors are solutions of the system of differential equations.